For question number 1, you are being asked, what are the 4 ways that you can solve a quadratic equation? And the 4 ways are the following: factoring, completing the square, the quadratic formula, and then if you were to graph it, if you were to graph the function, then you would identify the x-intercepts, and that would be the solution. Number 4 was not available to you because your test was a no calculator test, so potentially that's why all of you got that question wrong, but it's cool. Okay, number 2, you are being asked to complete the square on the following quadratic equation. You should recognize this is the general form of a quadratic equation in standard form. Okay, if we're completing the square, we want to make sure that we divide the left and the right side by the leading coefficient. And so we will have x squared plus b over a x plus c over a equal to 0. Okay, then if I was completing the square with numbers, I would move the constant over to the other side. And I'm going to do the same thing in this scenario, even though I'm dealing with only letters. Letters are your friends, sometimes. Okay, why did I put this random fill in the blank? Because I'm trying to make a perfect square trinomial. And if I want to make a perfect square trinomial, then I need to figure out what that constant should be. Okay, that number that goes there is the middle term divided by 2 and then squared. So b over a divided by 2 is the same thing as b over a times 1/2, which is b over 2a. Then we have to square it. So that would be b squared over 4a squared. So that would be the number that goes here. Oh, no, sorry. B squared over 4a squared. Perfect. Now we have a perfect square trinomial. We have completed the square. Okay, if I added b squared over 4a squared on the left side, then I must also do that on the right side. Cool. Notice that these are not like terms. So we have to make them be like terms by multiplying that first fraction by, hold on, let's see if I can drag things out. Yes, cool. I'm going to multiply that first fraction by 4a over 4a, because if I do that, then both denominators are going to be 4a squared. Okay, so negative c times 4a is negative 4ac. And then we have that b squared, and then everything can be written down under 4a squared because they have the same denominator. Okay, cool. Now the factored form of this perfect square trinomial is x plus b over 2a squared, and we said that that was equal to negative 4ac plus b squared over 4a squared. And if we want to undo squaring something, we take the square root. And what we do to the left, we must do to the right. And so we have x plus b over 2a is equal to plus or minus. The numerator is not a perfect square. The a and the c kind of ruined everything for us. So we could still simplify the denominator because 4 is a perfect square and a squared is obviously a perfect square. So we're going to do this. Negative 4ac plus b squared over 2a. Okay, next thing we are going to subtract b over 2a from both sides. and I'm gonna continue working on the right side. So we have x is equal to negative b over 2a plus or minus the square root of, okay, what I'm gonna do now is I'm gonna swap this term with that term so that the b squared is first. You're allowed to do that. Think about it. Is negative 5 plus 4 the same thing as 4 minus 5? And yes, they both equal to negative 1. So we are allowed to change the order of the terms. Okay, the denominator is still 2a. Do you notice that? Do you notice they have the same denominator? Perfect. That means that we can write everything as a single fraction. So we have negative b plus or minus the square root of b squared minus 4ac over 2a. Bam! You just derived the quadratic formula. Okay, number 3. The ages of 3 siblings can be expressed as consecutive integers. Consecutive integers are numbers like 2, 3, 4, or 7, 8, 9. That means that they're right next to each other. If these were unknown consecutive integers, then a way to show that they're consecutive would be to say, okay, I don't know who is the youngest one, but I'm going to let the youngest one be x. So then the next one must be x plus 1. And then the next one has to be x plus 2. Right? So that's what we're going to do in this problem. Let's write this up here. Perfect. Okay, so the square of the age of the youngest sibling. Okay, I'm going to stop right there. The square of the age of the youngest sibling. That means take my x because that's my youngest child and square it. Then that word is means equal sign. 4 more. That means 4 plus 28 times, so 28 times multiplication, the age of the oldest sibling. The oldest sibling is x plus 2. Bam. So now we have x squared is equal to 4 plus 28x plus 56. And if we simplify that a little bit more, we get x squared is equal to 28x plus 60. And what we're going to do now is we're going to rewrite this equation in standard form. X squared minus 28x minus 60 is equal to 0. And now you're going to try and factor that. Find two numbers that multiply together give you negative 60, but added together give you negative 28. So we have x, and I think those two numbers are going to be 30 and 2, with the 30 being negative and the 2 being positive. Therefore, x is equal to 30 and x is equal to negative 2. We can recognize that this is an extraneous solution because ages cannot be negative unless we get super philosophical, which we're not going to do. Okay, so therefore x, or aka the youngest brother, is 30 years old. But the question is asking you for the middle sibling because I am evil and I was trying to trick you. So the middle child is 31. Okay. If you solve this problem by creating an equation, did you get an extraneous solution? What was it? Well, if you did it right, you got that x is equal to negative 2. Okay. Number 5, we have x squared is equal to 26 minus 11x. First thing you want to do is anytime that you're solving any quadratic equation is that you want to set it equal. You want to set it in standard form. Okay, A lot of us went straight into trying to complete the square, and that was a very, very respectfully dumb method of doing it. First of all, factoring, especially if you don't have a leading coefficient, like in this case, should be your first go-to. If you don't have a leading coefficient, you should see if you can factor this by inspection. Second point, if you're trying to complete the square on this, you are going to end up with fractions. You are going to end up with this. And I am not trying to add 121 over 4 to 26. That should not have been your first go-to. So anyway, let's see if we can factor this. If we cannot factor this, then yeah, we can try completing the square. Are there two numbers that multiplied together give us negative 26 and added together give us 11? If my math is correct, I have a feeling that 13 times 2 is 26, and then the 13 should be positive and then 2 should be negative. Oh my gosh. I have two numbers that multiply together give us negative 26 and added together give us 11. Therefore, x must be equal to negative 13 and x must be equal to 2. Great. And I didn't even have to complete the square on it. Okay. Just like the last problem, we want to put the b squared on the other side so that we have a positive leading coefficient and so that our equation is in standard form. Cool. Can I factor this? First of all, I know that 19 is prime, and the only numbers that multiply together give us 19 are 1 and 19. So the difference between 1 and 19 will never be negative 8. So that looks to me like I might have to complete the square on it if I'm not allowed to use a quadratic formula. But look, I was also not trying to trick you here. The middle term is even, which means that if you divide it by 2, you will not end up with fractions, which is good. Okay, let's see. B squared minus 8b plus something is equal to negative 19 plus something. What number would make this a perfect square trinomial? That number would be negative 8 divided by 2, which is negative 4, and then squared, so 16. And if you're adding 16 on the left, you must also add 16 on the right. Okay, the factored form of this perfect square trinomial, what two numbers multiplied together give you 16 and added together give you negative 8. That would be b minus b minus 4 times b minus 4, or b minus 4 squared. And then on the right side, we have negative 19 plus 16, which is negative 3. If we take the square root on both sides, then we end up with b minus 4 is equal to positive or negative I times the square root of 3. Therefore, b must be equal to positive or negative I square root of 3 plus 4. Okay, number 7. Again, let's rewrite this in standard form in such a way that you end up with a positive leading coefficient. So I'm moving everything to the left. I will have 6r squared plus 7r minus 3 equal to 0. Okay, this is a situation where it might make sense to complete the square, but I have a little bit of a hesitation, again, because that middle term is odd, which means that I'm going to end with fractions. So I might actually try to factor this by splitting the middle term before I try to complete the square on it. Okay, especially since a times c, in this case 6 times negative 3 is not such a big number. 6 times negative 3 is negative 18. Can I find two numbers that multiply together give us negative 18 but added together give us 7? Maybe, I think 9 and 2. And let's make the two negative so that when we add them, we get positive 7. So now we have 6r squared plus 9r minus 2r minus 3 equal to 0. You want now to factor by grouping. which means that you factor out the greatest common factor out of every binomial. So the GCF of the first binomial is 3r. So into the parentheses, we will have 2r plus 3. And then the GCF of the second binomial is -1. So we will end up with 2r plus 3. Perfect. You see how these two are the same? That means that this equation is actually factorable. Some of you, if you do this and you don't end up with two common factors, then the equation is not factorable. You can't force it. So we have 3r minus 1 times 2r plus 3 equal to 0. Again, your friend, the zero product property. You have two factors that are being multiplied together, and when they're multiplied together, you get 0. So either 3r minus 1 is equal to 0, or 2r plus 3 is equal to 0. Solve for r, you add 1 on both sides. You divide by 3, so 1/3. You subtract 3, and then you divide both sides by 2, so -3/2. Number 8. Number 8 was review from semester 1. Disappointing that so many of you forgot how to do this. Try to logic your way out of these problems. Okay, so we have a little variable. We are subtracting it from 7. There's a radical. We're multiplying it by 4, and we're adding 8. Okay, try the first thing, which is get rid of that 8. Move it to the other side, so you have to subtract 8 from both sides. So what do we have? 4 times the square root of 7 minus x is equal to -12. What's the operation happening between this radical and that 4? Okay, it's multiplication, right? So that means that I should be able to undo multiplication by 4 by dividing by 4. So now I have the square root of 7 minus x divided by -3. How do you undo a square root? You undo it by squaring both sides. So I have 7 minus x is equal to 9. How do you undo having a positive 7? Remember we talked about being able to switch these two terms around because -4ac plus b squared is still the same thing as b squared minus 4ac. If the idea that the opposite of having a 7 is to subtract 7 is weird to you, you can rewrite it like this. -x plus 7 is equal to 9. So it is more obvious to see now that the opposite operation is to subtract 7. So we end up with 2. And then this is where I was very, very sad because a lot of you did, oh, the opposite of this is to add 1 on both sides, and so x is 3. But that is not the truth at all. There is an invisible number on the left side of the x. That number is 1. What's the operation happening between the -1 and the x? Multiplication. So you should not be adding anything. You should be dividing by -1. And that is not okay to be doing that mistake in Honors Advanced Algebra 2. You need to know that there's an invisible 1 or -1, and that the operation happening is multiplication, and that the opposite of multiplication is division. Like, you need to know that. Okay, so bam, x is equal to -2. I'm done. No, you're not. If you remember when we were doing radical equations, we learned that you have to check for extraneous solutions. So if we were to substitute -2 back into the original equation, let's do 4 times the square root of 7 minus -2 plus 8 is equal to -4. Okay, 7 minus -2 is 9. 4 times the square root of 9. Isn't the square root of 9 just 3? So 4 times 3 is 12. And 12 plus 8 is 16, and 16 is in fact not equal to -4. So there is actually no solution to this problem. Sad. And honestly, you could have seen that just by looking at the original problem. Watch. Multiplying something by +4, well, that's going to be positive. Because if you were taking the square root of something, that can only be a positive number. If you take the square root of something, you will not get a negative answer. So a positive times a positive is a positive, and then you're adding 8. That's another positive. So how on earth are you going to end up with a positive left side equal to a negative number? You can't. Number 9, rationalize the denominator. For these kinds of problems, you are going to multiply the top and the bottom by the conjugate. So square root of x plus 5 over the square root of x plus 5. I'm actually not going to try to FOIL here. I'm going to leave it like this, just in the off chance that something will cancel out. Remember, this is a difference of squares, so I can represent this as the square root of x squared minus 5 squared. So I have parentheses x minus 25 square root of x plus 5 over the square root of x squared is just x, and 5 squared is 25. Aha, these are the same, so my final answer is just the square root of x plus 5. And then lastly, why is it called rationalizing the denominator? I wasn't looking for something super deep. I was just looking for you guys to say that the current equation has a radical in the denominator. So you are rationalizing the denominator by getting rid of that irrational number in it. That's it. Okay, bye.